Hi, question number 2. By drawing a suitable pair of graphs, show that the equation cot 2x is equal to sec x has exactly one root in the interval 0 less than x less than half pi. Part B, show that if a sequence of real values given by the iterative formula x sub n plus 1 is equal to half tan inverse of cos x sub n converges, then it converges to the root in part A. Well, how do we go about and sketch a graph like this? Cot of 2x equal to sec of x. Now, it must be remembered that y is equal to tan x, the graph basically looks like this. And because there's a 2x over here, if I say tan of 2x, then this is going to come pi upon 4, minus pi upon 4, pi upon 4. So these are my vertical asymptotes. Why? Because we know that 2x can equal to plus or minus the original vertical asymptotes pi over 2. So the x is going to then become, this is the vertical asymptotes, pi upon 4, if we divide by 2 on both sides. So now the graph is supposed to go like this, okay, and then it passes. Now this is our vertical asymptote. So the vertical asymptote is here. But now, if this was our graph of y is equal to tan of 2x, but we're looking at cot of 2x, so the graph is supposed to go down like this. So the vertical asymptotes, where it crosses the x-axis, becomes the solution to this. So therefore, the graph is going to go like something like this. Going to end at pi upon 2. And in the question, we're supposed to sketch the graph for 0 being less than x less than pi upon 2. So this is my y is equal to cot of 2x. And what about sec of x? So sec of x is basically starts here from 1, because we know that this sec is, if you were to have your, let's say, cos graph, it's going to go like this. That's your y is equal to cos of x. Now, what about sec of x? And sec of x we know is 1 over cos of x. So it's going to start here and go up like this, like this. So what we're saying then is that the graph starts here and go up, and it goes up like this all the way to pi upon 2. So it crosses one solution here, that's one root, okay? So this could be alpha. Right, and therefore what we can conclude is that, so the two curves intersect at one point over here, giving one root between these intervals. So that's the first part of the question 2. Now for part B of the question, we need to show that x to the sub n plus 1 is equal to half tan inverse of cos x sub n converges to the root in part A. So the way we do this, we're just going to swap around the formula. So 2 times x is basically 2x, and I'm going to remove the sub, this one here, n plus 1, and remove this one. So I end up with 2x equal to tan inverse of cos of x. So the tan can go on the other side, becomes, the tan inverse becomes tan of 2x on the other side, and we got cos of x. Remember that this is multiplied by 1, and this is also multiplied by 1. So I can say then 1 over tan 2x, so 1 over tan of 2x is equal to 1 over cos of x. And, well, 1 over tan of 2x is cot of 2x. And so cot of 2x is equal to 1 over cos is sec. So sec of x. And so therefore this has been shown that it converges to the root in part A. So this is the second part of the question. Take care.